touched on it before, but I actually looked up some answers here, and yes, it was difficult, so enjoy. Centripetal force and centrifugal. Centrifuge versus centripetal. Centripetal. These are things that tick people off for very good reason. I'm going to leave the definitions below and you can look them up. The Earth orbits the Sun. I've said this in another video, but I'm going to retread this a little bit. The Earth orbits the Sun at approximately 66,600 miles per hour. That's effectively along its circumference of the orbit, the actual speed the Earth is going around the Sun. And coincidentally, the Earth rotates on its axis at about 1,000 miles an hour peak at the equator. This is rough numbers. It's actually slightly faster than that. I'm just using a round number. It's actually slightly faster than what would be the speed of sound relative to space, the final frontier. And with reference to the background, the cosmic background radiation that indicates strongly that something happened a very long time ago. It's very, very much shifted in frequency. And being able to measure that, we're able to determine that our solar system and our galaxy are actually moving through space at a specific speed too. The speeds are insane, but then again, if you're in a car and you're sitting there, juggling ball, picking up a ball and it's not changing anything inside of the car. Unless you have wind blowing you in the face, you're not going to notice any real movement as long as you maintain a speed. But anyway, this 1,000 miles an hour at the equator takes 24 hours because the Earth is insanely, obnoxiously, monumentally huge. If you're at the North or South Pole, you're not moving very fast, but you can sit there and you basically rotate really slowly. If you've ever done any self-torturous behavior, like look at a clock that you're waiting for the end of school, you know how pain in the ass it must be to experience just a few minutes if you pay attention. That watched clock and that watched pot that never boils thing. But literally, the Earth goes around the Sun. It takes a year. There's not enough speed for it to whip you around and whip you back and forth and throw you off. And even at 1,000 miles an hour or over that, at the equator, you're not really moving that, you're not moving a large amount of momentum here. But what is the actual effect of the Earth rotating on its axis at the equator versus if it was stopped? If you could, use both reference points and check them. Surprisingly enough, getting a straight answer out of a bunch of eggheads is a pain in the rump. Now, most people watch my channel figured out a while ago that I'm, for lack of a better word, I'm a flaming liberal. I'm more of an anarchist. I'm not a conservative. But I cross paths and agree with people on both sides of the fence because the fence is irrelevant. But one thing we all can agree on is when someone goes out of their way to make something harder to understand, sort of like a bunch of people I do videos about, so that they can keep their little position in life a little bit more secure by making it complicated, that's kind of annoying. Now, there are some times when it's legitimate. Using specialized language sometimes is required for clarity. For instance, if I state that the impedance in a electrical system like a speaker or just coil of wire in a capacitor or whatever, impedance at this frequency is an impedance rather than a resistance, which is pretty close. It's a similar thing. That means at that frequency, the impedance is like a resistor only at that frequency. At a lower frequency, it'll be a different impedance, and at a higher frequency, it'll be a different impedance. That's actually technically very important because impedance, even though it just means to impede and therefore resist, even though they're the same words, they have a very specific meaning for a specific set of circumstances. And it's basically you borrowing a word to make it different than the most common word. For instance, reluctance, which is the same kind of thing. This is for inductors. Capacitors have another one like it that's also, I forgot the name of it, but it's another term. The reason we have these specialized words is because the English language is delightfully dumb when it comes to making these kind of distinctions, so we just borrow literally pseudonyms. That's how we do it. So let's talk about me getting angry at Wikipedia and wanting to slap the crap out of people sandbagging it. And yes, in this case, you'll figure out which group sandbagged it. The polar circumference of the Earth is circumference. That means the distance around from pole to pole is 24,859.73 miles. If you were to get out and measure it, it would be that average. As the Earth rotates on its axis, you could measure this, and you'd get that average. Remember, there are mountain ranges and, seafloor to consider. And its radius, not diameter, but the distance from the core of the Earth to the surface, at the poles, that's really the radius going from pole to pole only, which is confusing, is 3,949.9 miles. So it's almost, and this is averaged out again because it's based on the circumference that we did, where you can do it from all sorts of different positions and you're averaging it out. It works out to 3,950 miles almost exactly. And the equatorial circumference, or the distance around the equator, this makes a lot less problems because we don't seem to think that this would be as difficult to do, because it isn't. So anyway, it shouldn't be, is 24,901.461 miles averaged, because it is averaged. And that works out to a radius from the core, but only going around the equator, of 3,963.2 miles. So it's plus or minus, if you were dealing with the depth to the core of the Earth, here we go, with the whole point of me doing this particular video, right, well, mostly, of 3,950 to 3,963 miles. So it's plus or minus, 13 miles or so. Is that actually right? Yeah, plus or minus 13 miles. And it's a specific amount, and it is a gradient, which means as you go further and further north, it goes to one value, and further towards the equator, it goes to a different value, because of these different diameters or circumferences. And remember, simply because the Earth is able to be measured this way, only really one way, and this way from lots of different angles, the averaging is going to be different. Because it is. We don't do it specifically on the International Date Line or Greenwich Mean Time as the line we draw to go around the Earth here. Yeah, that's really what it is. So anyway, and yeah, you could do, I suppose you could average it by going at a 45-degree angle-ish kind of thing across the equator on 2 points, and use that as your math equation to come up with the average diameter or whatever, which works out to diameter, which should be double 3,950, works out to 7,917 miles approximately. I'm rounding it off here because this is a pain in the road. Now, all these numbers are annoying, but basically I always round it off to 4,000 miles rather than 3,000 something to do a basic thing, because it's only off by 50 miles, because we're just doing a basic ratio to figure out things in the past that I've done. But anyway, to figure out how much you actually experience due to the rotation of the Earth as far as it changing your weight. See, this whole idea is, well, we're flipping around the Earth at 1,000 miles an hour. That's not possible because the Earth can't be round, because it would mean that we're spinning at 1,000 miles an hour and we're being thrown off in space. Okay, well, let's actually talk about this for a minute. No, let's talk about that idea. Let's see if that would even possibly happen. Now, this is when it gets pear-shaped, pun intended, trying to find out an answer on the internet, on Wikipedia and other places. How much would you weigh at the North Pole versus at the equator due to only the spin of the Earth? Not due to the diameter changes and the amount of rock underneath you being different, but just to the centripetal or centrifugal force. Yes, you have to use the proper terminology in the wording. And if you're curious about it, here's the simple answer, and I'm going to put it in the title for the video. You weigh 100 pounds at the North or South Pole, either one, even though that's not really technically accurate because of the amount of material. But at the equator, strictly due to the fact that the Earth is rotating on its axis and you're going at about 1,000 miles when you're nearly 4,000 miles from the center. So it's like you're being on a tetherball that's 4,000 miles out there being whipped around, but it takes all day for you to spin around. It does actually make you weigh less by, if you have a 100-pound object, if you're a 100-pound person, soaking wet, you'd weigh 5.5 ounces less at the equator. Now, I'm going to extrapolate that and assume that if you weighed 200 pounds, pretty average, you'd weigh almost 10 ounces less, or 1 beer's worth. So let's just say it's 1 beer for a 200-pound person, and it's, I don't know what it would be for the DMT. Maybe it's a double-shot mocha for the other side. Anyway, your mass is measured that way, and your weight is measured. Now we're going to get into the part that annoyed me. When I tried to look up centripetal force and centrifugal force, I looked up the formula because I wanted to actually do the formula myself. I thought that'd be impressive, and the fact is I've tried it before, and it's annoying because it's really annoying. And then I ran into a few things that I don't like hearing about, so I'm going to bring up my favorite one here. Talk page for the fictitious force. No, that wasn't the original name for it. Someone sandbagged an article on something that isn't fictitious by using one of the meanings for fictitious, which is illusory or virtual, or apparent force. The apparent force caused by the Earth rotating on its axis lowers your weight by 5.5 ounces for every 100 pounds at the equator. The apparent force of rotation. It's not a fictitious force, obviously, and fictitious is a loaded word. Trigger warning. And when you look up in the talk page, and I'm going to leave a link to it, please change this entry to read apparent force because reasons, and then you see flat earthers wanting to make it fictitious. The only thing worse than that very obvious attempt to just shit on science, let's all shit on science, is looking into the references in centrifugal versus centripetal force for a formula. Guess which one doesn't have the formula that I was looking for? And if you're wondering about this is the centrifugal force, centrifuge force, or, swinging a weight. Now I'm going to read a quote here. This is a bad quote. Your mass in grams stays the same because grams is a measure of the resistance of a body to being moved. That's referring to inertia. Why didn't you just use inertia? Because that would make it easy for everyone to understand. Anyway, going on. And it has nothing to do with acceleration or gravity or weight, which is usually measured in pounds. Your mass in kilograms would remain the same even in no gravity because it's mass. It is common for people to use pounds and grams interchangeably. Yes, because that's what normal people do, you egg-headed twit. But they're not. Grams is for mass, and it's a science measurement. This is an assertion that was taken seriously in a discussion somewhere I'm not going to mention. You can find a link below, maybe. Mass doesn't change whether you have gravity or not. And gravity is the equivalent to acceleration. But it isn't acceleration. It is in a very, very real way in physics the equivalent to acceleration. But it is not in itself acceleration. And mass, not grams, is a reference to something that doesn't change whether there's gravity or not. It deals with how much material or matter is in you. And weight is a relative term. But you can measure them in grams or pounds or whatever you want to. You can measure it in gerbils. The point is, they are directly equivalent to each other. This kind of extreme literalism right next to somebody sandbagging an article by getting rid of its real name, these both tick me off. One of them is an egghead, the other one is an asshat. Thanks for watching, have a good day, and good luck with that, and I'm sorry for sharing this extreme-ish stuff. Bye.